Hi all, in this one let's take a look at the concept of an inverse function, and specifically we're going to learn that when you talk about a function that's inverse you really need just one graph, and all the information that you need is contained in that one graph. So it's going to be a bit of a departure from perhaps the way this is normally presented in school, just to show you the essence of it. So imagine a relatively easy function. I'm going to begin with, say, y equals 2x plus 1. Let's just make a picture of this before we do anything else. Let me enable my grid here so I can make a good looking picture. Let's see, this is going to be my x-axis. Let's make this our y-axis. Zoom in here, so x and y. And I'm going to make a picture of 2x plus 1. Now, I know that just by looking at this, because I've done this a lot of times, that basically the slope is 2 over 1 and the y-intercept is 1. So these are the key pieces of information. This is the y-intercept over here. And the slope, if you remember back, is that value right there. That's where I got the 2 over 1. So let's mark this up and let's see what happens here. So I mark my y-intercept. I'm going to make each space 1 unit so I can make a big exaggerated picture and it's easy to see everything neatly. So this is that. This is my y-intercept essentially. And then the slope was 2 over 1. So that means I'm going to do this. I'm going to go 1 this way. 2 spaces is 1 here. And then 1, 2 up to that point. So let me do that. Mark this point over here. So this way and then over here. And then I just connect this with a straight line. Double-ended, for example. So that looks like this. And that's pretty much my function. Let's also add some numbers along the axes here. It will help to keep track of everything in detail. So this is 1, 2, 3, 4. That's enough. That's 1. So this is 2, this is 3, and say this is 4 over here. And at first, it is true that this simply is the graph of y equals 2x plus 1. But then, take a look. We're going to find the inverse. So to find the inverse, what it in its essence amounts to is this, being able to reverse our function. So since this function multiplies by 2 and adds 1 after multiplication, that means we're going to find the inverse simply by doing this. Here's the key step. Solve for x instead. That's the key step. So let's do that. I have y equals 2x plus 1. I will have y equals 2x plus 1. So I subtract 1 from both sides as an example. So y minus 1 equals 2x. And then I divide through by 2. So it's going to tell me that y minus 1 over 2 is the value of x. This is the inverse. This is the function that tells you for each y now what is the corresponding x that is output. So notice that y is in this side now. Y is part of this expression. So now basically what it says is choose values from the vertical axis, subtract 1 divided by 2, and that's going to give you a corresponding value on the horizontal axis. That's the essence of reversing whatever this one has done over here, which first takes x and produces y. The new one takes y and produces x instead. So it's reversing in that sense. So the question is, to break with convention, do we really need 2 graphs? And the answer is no. One graph is both the function and its inverse. It's just a matter of deciding how you choose to read that one graph. So let's see here. If arbitrarily, let's say, I don't want to make anything too thick here, I decide to read the graph this way. So imagine 1 is going in, then as you can see 3 will come out. So I'm beginning over here. X equals 1 is my input. I go through the graph out to the y-axis, and then 3 is my output right here. To read the inverse, you simply reverse the steps. So in other words, you're going to begin here, you're going to go this way, and then back down to 1. You see that? So the idea is the following. Let me add a note here. That this graph, y equals 2x plus 1, is the graph that you see when you read this way, from the horizontal over to the vertical. So when you read from x to y, that's my little symbol for reading from x to y. On the other hand, when you solve, you're going to have y minus 1 over 2 equals x. So this is when you read the opposite way. In other words, when you read first from the y back to x. That is the inverse. And that is all that you need. Just one graph that contains both pieces of information. Conventionally in school, this is always presented in a way where you have a function, you form y equals x, and then you reflect across that line. And that's fine, but that's only because our desire is to always have the independent variable along the horizontal axis. It's a matter of convention. It doesn't actually have to be that way, because when you look at a graph, there's nothing whatsoever that says that you have got to always read from the x to the y. That's just a conventional way of reading things. There's nothing in nature that dictates that. Which means we can just as easily read our graph from the y back to x. That's all. It's a matter of perspective. And now let's do one last thing. Let's just actually check this with a point to be sure that we've done everything in a mathematically sound way. Let me just disable the background. I like the white background more. And now imagine this situation. X has the value 1. Let's just confirm everything mathematically. So when x has the value 1, and I'm going to use the original y equals 2x plus 1, I will then have that y equals 2 times 1 plus 1. Work that out, so y equals 3. Now that is confirmed in the graph in the sense that you see here, let me emphasize this key point, x equals 1 is right here. When that first goes in, and if you trace it, then it goes this way and then over to 3. So that agrees. So the inverse then says that if you reverse this, we should begin on the 3 and get back to the 1. Let's actually see that in action though. Algebraically, not just graphically. I like the graphical approach, I think it's insightful. But let's confirm it. So that tells me that when y has the value 3, I should get out the value 1 as x. So I'm going to use the inverse for that. In other words, I am going to use this one. Y minus 1 over 2 equals x. Let's check it. So I will have 3, my value of y, minus 1 over 2, that's x. So let's simplify that. 3 minus 1 is 2, 2 over 2 is 1. So it confirms that the following is true. Whatever 2x plus 1 does, y minus 1 over 2 reverses in the following sense, that when x equals 1 goes in, 3 comes out, and then when you feed it with the inverse by reading the graph backwards, essentially from the vertical back to the horizontal, it produces 1 as the output. And you see that right here. So what it's telling us is essentially this, that for a function in its inverse, the point should be reversed. In other words, if the point, for example, 1, 3 is on f, so we have that right here, take a look, this is the point. Let me emphasize this, this is 1, 3, where this is read as the input 1 goes in, 3 comes out, along the vertical. We have that. Then for the inverse function, which is notated by writing f with a little negative 1, we should have the point, for f inverse, the point 3, 1 is on it. Now the question is, do we have that? Yes, we do. Take a look. Go back to the curve and break convention, so to speak. So instead of reading from the horizontal to the vertical, read the opposite way. And when you read this the opposite way, 3 is the input and 1 down below is the output. So in other words, 1, 3, this is on f, and then 3, 1 is on f inverse. It's there. So one graph contains both, depending how you choose to read the axes. Let me zoom out even more here. I want to make sure you can see everything. Please leave a like.